The effect of temperature changing on an equilibrium. Well, there are exothermic reactions and endothermic reactions. Exo is like exit, things going out, heat going out. So we can think of heat as being a product in an exothermic reaction. So what might that look like? Well, we might have like A plus B goes to C plus heat. It's producing heat, exothermic reaction. So if we raise the temperature of this, I should have made that an equilibrium, because that's what we're talking about in this chapter. If we raise the temperature, that's like adding heat, isn't it? Because how do you raise the temperature of something? You put heat into it. You put heat energy into it. So raising the temperature is like adding heat, adding a product, and what does that do to the equilibrium? It shifts it to the reactants, to the left, right? In an endothermic reaction, we can think of heat as being a reactant. So this might be something like A plus heat is in equilibrium with B plus C. You have to put heat in to make the products form. Now, if I put heat in here, if I increase the temperature, that's going to shift the reaction away from that to the right. The opposite happens when we cool it down. If I cool it down, if I lower the temperature, that's like removing heat. Removing heat will cause the reaction to shift towards that. So here we have an exothermic reaction, nitrogen plus hydrogen in equilibrium with ammonia, and heat is being given off. If we increase the temperature, that's adding heat, causes to shift to the left. If we decrease the temperature, that's like removing heat, and that causes the reaction to shift to the right. The reaction equilibrium will shift to fight against how it has been disturbed. An endothermic reaction. Here, heat is one of the reactants. N2O4 plus heat in equilibrium with NO2. If we increase the temperature, we add heat, the reaction shifts away from that. If we reduce the temperature by removing heat, the reaction shifts this way to produce more, trying to replace what was taken away. This is an interesting reaction because N2O4 gas is colorless and NO2 gas is brown in color. And so we actually can see this happening. So here's a tube, a glass tube, and it's sealed. And this equilibrium is occurring inside this glass tube. Here it's warm. I don't know what. It looks like it's sitting in cotton or something. I don't know what that is. Anyway, when it's warm, if we add heat to it, it causes the equilibrium to shift to the brown gas, and the whole tube, the gas turns brown. And if we take this and cool it down, it causes the equilibrium to shift to make more heat, and it causes it to be colorless. And so this tube, you can make it go back and forth, colorless brown, just by changing the temperature. So another summary slide. Exothermic reaction heats a product. If we increase the temperature, reaction shifts left. If we decrease, it shifts right. The opposite happens with an endothermic reaction. There's a whole bunch of increasing, decreasing, left, right, shifting business going on, right? And so just memorizing these is going to be really challenging. But if you can think about what's happening, look at the equation. Okay, heat is a reactant. If I increase the temperature, I'm adding heat. When I add heat to this side, then it causes it to shift to the other side to try to get rid of that. It's trying to undo whatever we've done to it. Example. They're telling us this reaction is exothermic. If it's exothermic, is heat a reactant or a product? It's a product. So I'm actually going to write that in there because that will help us to think about it. What's the effect of increasing the temperature? It'll shift to the left. because that's adding heat. So if I'm adding to this side, it'll shift away from that. What if I decrease the temperature? It'll go to the right. Because now I'm taking this away. I'm removing, and it's going to try to replace it. Okay? That's how you think about these.